Alright guys, in today's video we're going to be diagnosing an intermittent air conditioning problem. What we've got here on this 98 Chevrolet K2500 is we've got a situation where intermittently the compressor will cut off. It only happens when it's very hot outside, a hot ambient temperature, and after the driver has been driving for 30-40 minutes or so, then you'll get these intermittent cutouts of about 5 to 10 minutes each, and then the AC will come back on again for some period of time, and then that'll repeat until everything cools down. This kind of problem is very unlikely to be refrigerant related. It's going to either be electrical or mechanical. So I'm going to show you my approach for diagnosing things like this, but let me show you the pieces that we're trying to eliminate from this equation. This is not something you can fire a parts cannon at. It'd be very expensive. You have to do a proper diagnosis. So for the electrical parts of this problem, there's several components, one of which is the cycling switch that's located over here attached to the accumulator. That's one thing that will be involved in our diagnosis. The next switch is attached to the compressor. This is the low pressure cutoff switch. The next switch is also attached to the compressor on the back side. This is the high pressure cutoff switch. And then the next is also on the compressor. It's in the front. This is the electrical connection for the electromagnet that operates the clutch. And then the last piece of this mystery will be the clutch itself. There's a plate here in the front that moves in when the magnet actuates it, and then the pulley surface on the front has a friction surface for that plate. So all of this is what we're going to be doing a process of elimination on, as well as the air conditioning relay that'll be located inside this box right here. And of course, incidentally or anecdotally, it'll also be the vehicle control module that's located here. The tests I'm going to show you will eliminate all of these things and zero in on the true root cause so we can determine a repair approach. So the only thing I'm going to be doing under the hood for this, most of this will be inside with a scan tool, but what I'm going to be doing under the hood is I'm going to come in here and I'm going to disconnect this wiring harness plug for the electromagnet. So what you've got on here is a couple of little prongs on the side of this guy. You can get yourself like a little mini pry bar like I'm using. You just want to lift these off gently and get them past these little prongs that you see here. And what I use for this is I've got my own little made-up harness here of OEM connectors. So this is this same connector here, right? And so what you've got is a dark green wire supplying current and a black wire for the ground. That's what we see. We get some of the dust off the back here. That's what we see on the original. I guess another component I should mention on this is right at the end of this harness, and this little kind of bulge that you see is a diode. There's a little container here for a diode. That's part of the circuit drain for this electromagnet. And so what we're going to do is we're going to stick our interface cable in here, and then we're going to connect it here. Now, why are we doing this? Well, for two reasons. One, this will also help me eliminate the possibility of either this connector or the electromagnet connector being part of the problem, and it'll also give me a place to attach some piercing probes to monitor from inside the vehicle the circuit while we're driving. So what we're going to be wanting to do when this cuts out while we're driving, we're going to want to be able to see on the scan tool what's going on with these switches that I pointed out before, as well as that relay. And then we're also going to want to monitor what's happening with the power being supplied to this electromagnet. If we get the compressor cutting out and there's no interruption of power, then we can isolate this problem to the clutch area. If we find that the power is being cut when the compressor goes off, then we can eliminate the clutch part of this, and we can focus on using the scan tool which of these possible switches were involved, or even the relay. So let me go ahead and hook everything up. I'll show you what the hookup looks like, and then we'll go off for the test drive. All right, guys, you can see what we've got under the hood here. We've got a couple of piercing probes on the positive and the negative going into the electromagnet of the coil, and then we've got those lines routed safely behind everything, and you can see over here in the left-hand side, passenger side, where we got it routed where it won't get pinched by the hood when we close it, and coming inside underneath the door seal. Let's go inside and I'll show you what we got inside for diag equipment. Alright, so here's the setup on the inside, guys. I got my Tech 2 scan tool hooked up. There's 4 PIDs we can monitor on this era of truck. AC request, AC relay, what they call the evaporator switch, which is the cycling switch, and the high pressure switch, which is the one I showed you on the back of the compressor. There's no monitoring of the low pressure switch. The default state for these 2 switches is closed and open, so this is normal. The evaporator or cycling switch should be closed to start with, and the high pressure switch should be open. If they detect a problem or if they cycle, they go to the opposite state. When we hit the button on the control module, the request is going to go to yes, and then if you have a diesel, the PCM, the powertrain control module, is going to enable the relay. If you have a gasoline engine, the VCM, or vehicle control module, which is under the hood, is going to enable the relay. So if we come up here, well, actually, let me show you one more other thing here. And then the other thing we've got here, you can see, is this picoscope, this oscilloscope, which is monitoring those 2 lines going to the electromagnet of the clutch. And if we take a look over here right now, everything is steady state except for some background noise on the positive side. So we got negative on channel A, the blue, and we've got positive on channel B, the red. So let's go over here. Again, it's no, it's off on the relay. We come up here, we hit this button. The LED lights up to tell us it's enabled. We come down to the scan tool. Now it has gone to the yes request state and the on state for the relay, and the 2 switches are still in the closed and open state, and we can feel the AC operating. And if we take a look at our scope, we can see ground is holding steady, and we're reading somewhere around 13 and something volts, which would be the alternator voltage that's coming off currently to the electromagnet. So this is what we're going to be monitoring. When the AC compressor cuts off, we're going to see, does this drop down? That's going to tell us if we're getting power cut to the electromagnet. If that stays on, then we know it's a clutch problem. If that drops out, we're going to be coming over to the scan tool, and we're going to be seeing, did this high pressure switch by chance flip from open to closed? Did this evaporator switch flip from closed to open, other than when it's normally cycling? Did the relay flip off? Right, these are the things that we're going to get out of this diagnostic. So it's going to take a while for us to recreate this problem. The last test drive, it took almost 30 minutes. Given the temperature out here, I'm hoping it'll be a little less, but whenever we get the event occur, I'll bring you back and I'll show you what we've got. So guys, as we're driving around here, I'm just going to show you on the scan tool, you see how this cycling switch is flipping on and off periodically. Right, so that's not what we're after. That's normal behavior. That's what its job is. But you can see when the cycling switch cycles, it turns off the relay. And right now the AC is still blowing cold. That's not what we're after, but I did want you to see what that kind of behavior is. Alright guys, we finally got it. You can see request is yes, relay is on. Our switch is in their default position here at this red light, but we're still getting voltage to the coil, but the AC is clearly off. So that definitely tells us something. We're going to see if we can capture anything changing when it comes back on here, because it usually just takes it a minute or so to do that. But I think we've eliminated with this test, I think we've eliminated that it is something related to the clutch, because power is getting applied to the clutch, but the compressor is clearly off. Actually, I'm going to see if I can pull over and confirm that. Well guys, before I could get under the hood, the compressor cycled back on again. No change in any of these PIDs, and the whole time I popped out and it was off and then flipped back on. No change in the voltage here either. So we definitely got a problem with the clutch. We'll take it back to the shop and see if we can figure out how to go. Guys, you can see the clutch is not going. I managed to pull over when it was doing what it was doing, and I'm hoping I can catch it coming back on here so we can see if it's mechanically moving, which might tell us something. This is the typical amount of time that it stays off, though. The other thing I'm going to do is I'm just going to make sure it's not a connection deal. I just really want to see the mechanical movement if it re-engages. That'll help confirm what part of the clutch that we have a problem with. Well, guys, I wasn't able to capture it on film because right when I was getting ready to stop, it comes back on again. But we can see while it's on, there's no gap. So that definitely tells us it's not a clutch friction issue. All right, guys, something else I wanted to be able to do when this is in a failed state is get an idea for how hot it is. We can see it's really hot where that coil is. Just a shy bit over 200 degrees seems to be enough to get us into this failure condition. All right, we're back here. You notice I've unplugged this because I'm going to show you one more thing. I let this cool down just a little bit. But what I'm going to show you is I'm going to go back inside and I'm going to start the engine. I'm going to turn the AC on. I want you to notice something about this type of diagnostic. And what you're going to see is even with this disconnected, we're going to be able to detect the output of the relay using the oscilloscope. So let me go show you that and then I'll explain why I'm showing that to you. Start it up. And then if we notice on the oscilloscope, if we turn the AC on, we'll see that red line jump up to 13 and something volts, just like we saw when we were doing the test drive. And if I turn the AC off, it goes back down to baseline with ground. Now, why am I showing you that? Well, that's important to this part of the diagnosis because we're using the oscilloscope to verify the rest of the electronics. We don't have a way to verify the electromagnetic clutch coil itself. So this can show voltage even if there's an open in this particular coil. So what's the repair here? Well, the repair here is going to depend on a couple of things. I'll give you my 2 cents worth. If this is an aftermarket compressor, AC compressor that you have on your truck, then my advice is to replace it, put a genuine OEM one on there to repair this problem. But this is an OEM GM compressor, so there's 2 flavors of this. This one here, this just bare aluminum, is a new type. If it's painted black, it's going to be remanufactured. My 2 cents on that is if you've got the black type from GM AC Delco and it's over 5 years old, just replace it. If you've got the new type, like this, and it's less than 10 years old, rebuild the clutch. If it's more than 10 years old, just replace it. You know, that's my advice. There's nothing in the GM service manual about this. It's just from decades of working on these types of vehicles. That would be my advice. So what's involved in the problem? Why do we have this problem? Well, this coil here for this electromagnet gets energized. And when current flows through this, that magnet pulls this clutch forward, like you saw in the previous clip. And then there's a friction fit between this clutch hub and an assembly here and the pulley assembly. And that's what then grabs the rotational force or energy of the belt and then actuates it so that it can turn the compressor shaft. That's how this whole thing works. If we look at a parts explosion here, we can see several things on here. These guys here in the front, like number 2, number 3, are all part of this clutch hub I'm talking about, the facing. And then this snap ring and this guy represent the pulley and the friction facing. And then inside of this is going to be this bearing. And all these things in green you can service while it's on the vehicle. Some of these models will have this little felt washer, and then there's our coil. Those are the things that we can service on the vehicle. This piece we can't, because if you accidentally remove this snap ring here, that's a seal and an O-ring that's retaining the refrigerant inside the compressor. That's a shaft seal assembly. If you do that, you're going to get injured because this stuff's going to violently shoot out. Frostbite, blindness, fill in the blanks, and whatever gets hit. You do not want to touch this stuff. This is a big do not touch. But all of this we can work on the vehicle without evacuating the refrigerant. So what is the problem though? Well, we saw in the video that we didn't have any engagement. So sometimes you can get a situation where this closes, but it slips. We don't have that problem. What problem we've got is we're not getting this pulled forward, and we see that it works fine when it's not hot. So what I believe we have going on is a thermally induced open in the coil, and that's the reason I wanted to show you that the oscilloscope is going to read voltage even when this is disconnected. So it's going to read voltage even if there's an open on this. If we were to get out an ohm meter right now and measure this coil, it would be fine, because once it cools down, the open closes. Once it gets hot, the open appears, cuts off the magnetism, this plate releases, and that's when the compressor stops working. So that's the problem. Now, something that could contribute to this is called the air gap, this space that we see. The service manual says that the specification for that is a minimum of 20 thousandths and a maximum of 30 thousandths. So if I come in here, you can see there's little grooves on the front of this. And if I come in here with a 28 thousandths, we can slide this in real easily, and you can see this guy. If we get the camera towards the front, we can see this guy sliding in there. Hopefully it's coming through. If I go to the next size up, which is the maximum that we should be doing here, which is 30 thousandths, right there, we can see that 30 thousandths is snug but still fitting. All right, so if that's the biggest that fits in here, then we're fine. But if I try the next size up from that, which I believe I've got a 32 in here. Let me find him. There he is. I got a 32 in here. And this 32, he's a little bit more snug, but he still fits. Fits real easy on this side. Fits really snug on the top, and you can get like uneven wear situations with these clutches. This side's also snuggish. So we already are at least 2 thousandths off, and I think the highest my current one goes to without starting to combine things. You know, I could combine things and get an exact measurement, but the 35 doesn't want to go in. Really have to push really hard, and it really isn't wanting to go in much further than this outer ring. So what we've got is the air gap is anywhere from 2 to 4 thousandths off. Is that enough to prevent the magnet from closing it? No, I don't think so. If it was 10 or more, I'd be inclined to adjust this gap as a possible fix, without having to replace anything. But for just 4 thousandths, I doubt that's a problem. Just to eliminate that variable, we will do that change, and let me show you the tool that's required to do that. All right, guys, I guess I'll go ahead and show you doing this air gap adjustment. So we're going to take this upper fan shroud off. Small prying apparatus or screwdriver to gently coax this clip off without breaking it. Stick that behind the upper compressor fitting. All right, there's 3 10mm bolts in the front, and then on each side there's 2 more. We'll just show you this side. We're going to go ahead and pull those next. All right, with all of those out, we've got one more clip holding this four-wheel drive axle vent. If you happen to have four-wheel drive, we need to pull that, and then we can lift this upper fan shroud. It's the same type of clip. Just going to stick this guy right there. And now with all of that disconnected, the shroud should just lift out. We had to do all that so we can get those tools in here. All right, so let me get the special tools and we'll go ahead and adjust this air gap. All right, so like we were talking about in the previous clip, we want to close this air gap. Before we can do that, we got to get this 13 millimeter retaining nut off the compressor shaft. You see these 3 depressions here are for a holding tool. Sometimes the belt is enough for this particular step, but I'll go ahead and show you this tool in case it's not. We'll just use it anyway. On the back, you see there's these little prongs, and we're just going to get them lined up into the 3 holes. I usually keep, one of them preset and aligned, and then the other one I leave flexible. All right, so now I'm going to go grab a 13 millimeter deep socket, and we can fit that right in through the tool onto this nut. And once you get the initial torque to release, you should be able just to hold it with your hand. Got quite a bit of rust on there. It's not a problem, just makes it a little harder to get off. All right, with this guy off, we got to have another special tool. So if we take a look inside, we can see that this is a threaded shaft. And there's a special tool required that threads onto the shaft to push this clutch in. It looks like this. This is actually an aftermarket version. All right, so this guy's going to end up threading onto that shaft. And then there's a thrust washer and a drive nut that completes the assembly. Right? Just make sure you don't cross thread it. And then I'm going to get a couple of wrenches to fit this tool, and then we'll just work this in, close the gap. All right, guys, for some reason, this is not properly threading on here, and so it kind of threads on, and so what I'm noticing is, even though this is a genuine GM compressor, this is not threaded to the specification. So the threading on these is supposed to be, it's an unusual thread pitch. It's M9 by 1.25 millimeter, and what I find here is it's actually threaded to M8 by 1.25, and that is incorrect, and that's why the tool doesn't fit. The tool has the same loose fitting on this M8 here. And I got a couple other tools that I can show you. Sometimes on the older compressors, you would end up having to use a different tool that's threaded for an SAE type. But even this one here is also threaded to M9. This is my Master Cool ones. This is a Master Cool and a Four Seasons. They both don't fit this. So what do you do in this situation if you hit this? I've never seen this before. Obviously the supplier screwed up, but there's a couple of options that I could suggest that you could do. So those two options are either you can take some 5/8 by 11 foot threaded rod like this, because that's the thread that the forcing nut needs. And you can cut this to length, then sand off the end, center tap it, drill it, and center punch it, drill it, and tap it for M8 by 125, and we could get it on there, and you could put a couple of jam nuts on it, or you could weld a nut on it. The other option would be take some 3/4 inch hex steel rod. This is 12L14 alloy, so it'd be good to machine, and replicate the tool, and this time instead of M9 by 125, tap it for M8 by 125. And of the two options, that's what I decided to do. So I took this rod down to a local machine shop that I work with and asked them to fabricate this for me. You just can't take this to a shop that does, like, you know, heads and stuff. It's got to be like a tool fab place. And they turned that rod into this, right? And now they've got this threaded to M8, and now this threads on just fine. So, you know, the cheaper route would have been the 5/8 threaded rod, but I wanted something that if I ever come across this problem again, working on somebody else's truck, that I have a tool that's going to last for a long time. So that's what we're going to go with. So let's go ahead and get our nut and our thrust washer, and let's get this thing, the gap rather, closed down on this. All right, so with this guy, I'm going to actually use my Master Cool's thrust nut, forcing nut and thrust washer, because it's a little thinner than the other one. And when they cut this, they made these threads just a little longer than I would have liked. So I'd be happier with it going on like this. So I'm going to get this guy going. This is the 5/8 piece of threading. And then we'll get this guy going. And then we'll thread this all the way on. We want it to get fully seated. In between the fan blades. And then I'm going to grab a couple of wrenches here and a feeler gauge. I'm going to take a 19. Just going to get it as tight as it can by hand, and then work this guy down. Notice it's a little beveled here. Just want to check something. This thrust washer is beveled on one side and flat on the other. I think what I want to do is flip this. I don't know that it matters, but it looks like it might seat better if we do it like this. All right, then I'm going to use a 26 millimeter, and we're going to work this guy down. And hopefully, we can get to a point where we can close the 30 thousandths gap so this guy no longer fits in here. So remember, he was kind of fitting in there just a little snugly, but that's the extreme end of the specification. So we want to get it where that's not the case. And we're going to go really slow because we don't want to go too far. You got to be patient with this step, guys. If you go too far, then you have to use a different tool to try to extract it out a little bit. It's starting to get tough. Tightening up. I want to get it where I can't get it in at all. Almost. All right, we're done. We can see what we ended up doing. Let's see if it goes in at 28. Yeah, 28 goes in snug. So we've closed this gap back into within specification. Like I told you guys, I don't think this is going to make one hill of beans difference on this, but we're waiting for the coil, so it was worth a try. And it was good that we found out that we've got this threading oddity so that we can get this tool made or get past that problem before we had the whole thing disassembled. So at this point, I'm going to put everything back together. I'm going to put the nut back on, 11 foot-pounds of torque. We're going to put the fan shroud back on. I'm going to wait for the coil to arrive, and I'll bring you guys back when we got the part to actually fix this right. All right, guys, I got the fan shroud back off. We've got our part now, so we can do this repair correctly. The air gap didn't change the behavior. It was worth a try, and that's why I showed it to you, but it would have had to have been more out of spec to be causing what we're seeing. All right, so before we get started, since we're going to be under here a little bit, I'm going to go over here and disconnect very gently so we don't break it, the connector for the under hood light, so we don't run the battery down while we're down here. And then even though I already showed it to you, I'll show you one more time, taking the special tool to hold the clutch plate and remove the 13mm fastener on the clutch shaft. Get this where I can hold it without hitting a fan blade. Okay. Take this guy back off again. And now, unlike the tool we used to close the air gap, we're going to use a different tool to open up the air gap. And then pull the plate off. Come on. I'll take this lock nut, we'll set him over here where he doesn't get lost. And we'll switch to that tool. So that tool looks like this. So this tool is going to thread in on the inside edge of the clutch plate. It's threaded for this special tool. And then the forcing screw, it's got a little point on it. It's going to sit in that little indentation at the end of the shaft. You try to get this guy to go in by hand as far as you can. And you want to get as many threads on there as you can for the amount of force we're going to be dealing with. It's a 26mm to tighten them up. All right, and then we'll run this guy down. If you want to, you can put some grease on here, but it's really not that much force. All right, I'm going to come over here from the driver's side with a 19mm. Going to hold things steady with the 26. And then we're going to work this guy down and pull the clutch off. If you watch up here, you can see that air gap opening up. Okay. Is that enough yet? There we go. And now we've removed this guy. So you can see it's like a friction fit right into there. There's a little key that you want to make sure you don't lose. It's going to fit right into that notch It's cut into the shaft. And then we can see from the factory, looks like there's some kind of shims in here maybe, although I don't usually see those. That's what that looks like. They're kind of cocked there. Let me get a little tool to see if we can wedge them off or wedge them back on and leave them alone. I think what we'll do is if they're going to be, now we'll take them off just in case they get lost. So 3 little shims from the factory. All right, the next thing we're going to take off is the pulley assembly. This little piece of felt is just to protect the inside. We're going to take that off so it doesn't get lost. In order to get this guy off at this point, we can take the belt off. Now this is a 5.7 liter Vortec. What I'm going to show you will be the same for the 5 liter. This is the tensioner for the belt right here. And then at the bottom is going to be an insert for a square drive tool like this 3/8 breaker bar. Pull that down. Never get your finger underneath the belt in case the tool slips. Just gently let that guy down. Let that back up. The shape and the design of the tensioner will be a little different on the 6.5 liter and the 7.4 liter, and I think also on the 4.3 liter. All right, now to get this off, we're going to have a puller. So let me go get the puller and we'll remove this pulley assembly. All right, guys, for the particular tool that I have is an aftermarket compressor pulley puller. The fan's in our way, so I'm going to have to remove that. Depending on the tool you use, you may or may not have to do that. The fan on this particular engine and series truck has some holes in the pulley, and this tool is designed to sit in those holes and hold it steady, while this tool we're going to come in and turn the nut. So if we look behind the fan, you can see this tool come in and sit into those holes. And then we'll be able to come in with the other tool, which will just act like a regular wrench if we can get it in just right. This 1/2-inch breaker bar. And not have it pop out on us. Yep. That one wasn't on too tight. Spin the fan off while holding the pulley, since we don't have the belt on anymore. You just don't want to let it drop. These old plastic blades could break. Okay, you don't want to let it hit the radiator either. All right, now we'll be able to come in and do our puller. All right, so first thing I want to do here is there's some road crud and grime covering up a snap ring that we need to remove. You want to get this outside snap ring. Don't want to touch anything inside the bore here. This big one on the outside is the one we're after. It's just years of road grime, dirt, stuff like that. All right, so we can see the holes now. Let's see if this pair of pliers will work or if it's too big. No, that should work. You definitely want to have some eye protection because these can take flight. And they're usually directional, like a bevel on them. So we just want to make sure we remember that this side faces out. All right, next thing that we're going to do is put the particular type of aftermarket puller I've got. So you've got these ridges that are part of the compressor housing, and that one's kind of like right in the way for this aftermarket tool, but we can make it work just like that, right? Now the other thing we're going to have to do is, this is going to be under a lot more force because of the bearing, and we don't want to put that much force on the compressor shaft. So there's a pilot that sits in, it's kind of beveled to sit inside the bore of the aluminum, and it shoulders the stress onto the aluminum of the actual compressor rather than all the stress going against this shaft. So we're going to put one of these pilots in here. If you don't use something like this, you run a good chance of damaging the shaft seal and getting a leak. Just got to hold this contraption together until we get it all lined up. It's centered. And when we do, you can then take a 15 millimeter and then just begin working this pulley assembly off. And again, if you feel like you need to, you can put some grease in the forcing screw right here. I don't really feel like that's needed on this particular type of application, just like with the one we did with the rotor. If you see, you can see we're closing off the gap we had with the aluminum as she comes off. And that pilot is small enough that the pulley's just going to slide right over it. You notice we're using hand tools here. Safest way to make sure you don't damage anything. As it gets near the end, I'm going to put my hand here just so we don't have anything drop and hit the radiator, tool, pulley, or anything. All right. And now this guy's off. Again, I'll put part numbers of several different brands of these tools I'm using down in the description. So this part of the assembly is all solid machined with the pulley, and then the bearing is pressed inside. So this is often why you'd be wanting to do this kind of thing, is to replace this bearing. This particular one is smooth, no sounds, no vibrations. If we found that it wasn't, we'd need to replace that too, but we're good. All right, so now that piece is out. And now's our prize. We're after this guy. So at this point, we can go ahead and remove the electrical connector again. I'm always very gentle on these because of their age. Come on, there he goes. Okay. Now this guy is also press fit on here. Pretty sure there's no snap ring on this guy. No, there's not. So he's just press fit into place. What I was looking for is there's usually some stake marks, and I don't see them on this one. You want to take note that the connector is going to sit in this crevice here. All right, so we're going to use the same tool again to pull this guy off. At least I hope. Let's see if he's got enough clearance. I don't know if this one's going to fit. Yeah, this is a pulley puller. It's really not going to fit this coil. Let me find a more suitable puller to get the coil off of here. All right, guys, the problem with our puller is we've got an arm that'll fit behind this electromagnetic coil, but the arm's too short to get the cross piece in. And I also still want to get the pilot in there, but I can't. So I'm going to show you what I'm going to try. I'm going to try taking a plunger out of this, because the shaft will fit right onto there. But I still want to not hit the shaft, so I'm going to try a little improvisation here. I'm going to stick a couple of washers on here, really thick ones. Yeah, let's just try with that. These are too small. And let's see if this will help us any. So now we can definitely get on here, and we can definitely push without pushing against the shaft. Now if I could just get something to keep the arms from wanting to move outward. Let me see if I can figure something out with that, and we'll come back. All right, this is on the sketchy side, but we're just trying to improvise with what we've got. Let's see if this gets this thing moving. Yes, it's coming off. Sucks we had to do this kind of Rube Goldberg setup here, but as long as we're able to do the repair, that's all that matters. All right. Yeah, so this tool would have been great if it had another arm that was just like in between the two. You know, it's got a long one and a short one, but this one is just not quite right. All right. I got this guy off, and we protected our shaft, and this was of sufficient thickness that it wouldn't bend under the force that was involved. All right, and of course, like I was saying at the beginning, we got all of our refrigerant with no problem. So now what we're going to do is just take a moment to clean up a few years of road grime, and then we're going to get it ready to put the new one on. Get some air and we'll blow that out. But first, let's take a look at the new one. So let me go fetch the new part and we'll come back. All right, we got this all polished up. Got some compressed air, blew inside the snout, let it sit for a little bit. Actually, I see I missed a little spot up here on top. And now what I want to do is make sure that we didn't damage anything. We're going to come in here with a refrigerant sniffer. Make sure we're not leaking any refrigerant. You can't get it any farther in than we've got, but if we had a problem, it would accumulate and be detected. So I feel like we got through this part of the repair without causing any new problems. So we can set this aside and move on. So let's do some electrical testing. So here's our old one. And we're going to set this meter to measure first continuity. So if I come up here and I make contact with this terminal and this terminal, it beeps to show that the winding's intact. And if I set it to resistance, we get a reading of 3.7 ohms. 3.7, 3.8. So something under 5 is what you'd expect. If we take our new one, which is a GM 655 2423 or an AC Delco 154440, this is actually a discontinued number. I'll put the current number and this one in the video description, but I just chose to get a discontinued one because sometimes you can get them cheaper just because they're discontinued. Do the same test on this guy. So we'll do the resistance test first. .8, basically the same. And continuity test. And that's the extent of the testing you can do. And so our old one passed those tests. The problem with the old one that we proved through testing is that it's got a thermally induced open in the winding. It gets hot enough, it opens up. So to replace this, what I'm going to do, let me get a small paper towel here. When press fitting on something like this, I like to take a little bit of 3-in-1 oil. So we'll put some of that all around here, and again, this helps make sure that we've got all the grit off. And while we're here, we'll go ahead and do the bearing surface for the pulley. All right? Because even with that, you get a little bit more dirt that comes off with the oil. I'd rather use the oil than brake clean or something because it'll help a little bit with the reassembly. Now to put this guy back on, normally the way GM would want you to do it is it'd be on the press, and you'd use this tool. There's a bunch of different manufacturers. Again, like all the other tools, I'll put several different brands you can choose, and it's got a little groove cut in it. You can see there's a raised point on this piece here, and this guy just fits in like that. And again, it's to let you drive it on without damaging this white thermoplastic type material that runs all the way down the inside, and also without hitting the shaft. So lining the connector up with the recess, kind of get that centered like that. Get the tool in position, and we're just going to use a dead blow hammer. Make sure she's going on straight. And then we're just going to drive her on. And actually, I'm probably going to have to get where you guys are to finish this off. But that's good and straight. So yes, I'm going to switch positions with the camera and we'll continue. Okay, if you guys take a look inside the snout area, you can see that we've got this back flush the way it goes, and our connector can be reconnected now. I switched to the brass hammer just to get a little bit more oomph out of it. All right, so now we're going to position our pulley. So let me go get the pulley and we'll put that back on. All right, we did the same cleaning out of the bearing surface. A little bit of 3-in-1 oil. Now on this guy, you want to be sure that you're hitting the inside race and driving that on. So there's another special adapter that goes like this to get that started. So we'll start it with the dead blow hammer, and then we'll put it the rest of the way with the brass hammer. So make sure it's going to stay put. And then we'll also use the same tool we did with the coil. Intermission, guys. All right, let's pick up where we left off. You can see we got about halfway. I'm just going to stop here just for a second just to show you, this is all meant to be put on a press, and so we're putting it on the vehicle. You got to be careful that you do these short sideways blows like I'm doing, because you definitely don't want to damage the radiator. That's why I'm going very slow here. Almost. All right, that looks like enough to get our snap ring on. Maybe just a little bit more on the bottom. Just give it a couple more whacks on the bottom. All right, let's give it a shot. Let's go grab our snap ring and our snap ring pliers. Get her finger up here to make sure she stays where we want her. All right, she's in. What you can also do is you can grab one of these and try to move it up and down, and grab the other one just to make sure that everything is seated, and have it twist just like that. All right, so it moves around. All right, so now we know that's good. We got a little bit more debris that got shook out by hammering. And we got some debris that shook out inside this bore for the clutch piece. So we're going to get that out of there. All right, and then the same thing we did previously. We're going to lube up the hub that goes in. But before I do, I'm going to reinstall this set of shims that we took off in the same order they originally were. And we're going to put this little felt washer back in, just the way we found it. And then we're going to take some more 301 oil right over here. And we're going to lube up this hub. All right, with the belt on, shims on, felt washer on, we chase the threads on the stud, make sure our custom M8 tool fits on okay. Now we've got to get this guy on far enough to use the tool. Make sure your keyway is installed, and we got to get the keyway above the shims and into the notch on the shaft. And you'll know you got it lined up if you can partially push it in by hand. Just like that. All right. Now, we've got to get this on far enough where we can get the tool on, because the tool's not going to thread on until we get it to where it can insert far enough to thread. And we have not done that yet because it's going to hit the keyway. So we're going to get a small plastic hammer or a rubber mallet that's of a small diameter would do. And we're going to hit the very center here only, just to try to get it on enough where we can use the tool. We don't want to use too much force here. You can deform this. Nope, I'm still hitting the keyway, so I can't thread it on yet. I can get like 2 threads. That's not going to be enough. All right, let's get a piece of wood, and that way we can use a dead blow hammer, and we can try to get it in a little further that way. All right, so what we're doing is we're just kind of tippy-tapping it on with this long piece of wood. We're trying to put it all around that center ring so we don't damage the spring and warp anything. All right, I think this is going to be enough. We'll blow some air in here in a minute, but I just want to see if we can get it threaded on. Yes, all right. So we're just going to go ahead and try to close this down, and then we'll blow out any little wood chips that might have gotten in here. So I'm going to switch over to the driver's side where I've got some more leverage. And this is just like when we were closing the gap earlier. We're going to turn the nut, and then we're going to hold the forcing screw steady. Between that and the serpentine belt, you should keep it in place while we close up this air gap. Actually, it's going to take me a longer time to do that than to do this. Now that we've got this in a little bit, all right, let's get some more threads on here. Now that we've closed that gap, we can get this on a lot tighter, have it not slip on us again. And then we should be able to finish closing this up. You see that air gap closing up, just like when we did this the first time. And what we're going to be after here is a middle of the road spec of 25 thousandths. We got a ways to go. We might have went too far. That's pretty snug. I got a little too aggressive with it. Let's see where we landed. 24. 23 is nice and snug. Yeah, no, we went too far, so we're going to take it out and use the other tool to open it up a little bit. It says grab our remover tool again. Sorry about that, guys. I really thought I had 2 more turns to play with there. So we'll just back it out slightly. In this case, we'll turn this guy. All right, and we're going to go back and we're going to re-aim for that 25 thousandths, just given the age of this guy. It's really where I'd like it to sit. Almost. That's it. 25 thousandths. We're done. Done if we can get our tool back. May have to get our little holder to. There he goes. All right, and then we've got that little 13 millimeter nut. Now that we've got it where it's supposed to be. M8 by 125, and we're going to blow out the stuff that's in here after we tighten this guy down, and then we're going to torque him to 11 foot-pounds. All right, we'll have to use our holder when we do the torque. I'm going to go ahead and torque it up, get some compressed air here, blow this out, put our fan back on and put our fan shroud back in and take it for a test drive. Alright guys, we got everything buttoned back together and our compressor is working just fine at the moment. We're going to go take it for a quick test drive, make sure everything's working okay with a short run, and then we're going to give it a run for the next few days and make sure the problem is finally fixed. We'll come back and do a follow-up when we complete that 3 or 4 day test run. Alright guys, 3 days later, no problem, so this unusual situation is finally remedied. The last thing I'm going to show you is just a few highlights from the GM service manual. So they have a combo tool that I'll list in the description that both uninstalls and installs the clutch plate, and they talk to you about doing that on a vise on the bench. And then removing the snap ring, they've got all kinds of special tools they're referencing here. They called the pulley assembly a clutch rotor. And then there's their version of the pilot, and then they have this tool that kind of slides into the slots that are on the top and then allows you to lift the pulley assembly off of the shaft. And then they go into changing the bearing, which is not really relevant. And then to remove the clutch coil, they walk you through those steps I just showed you, so they just repeat them again, same steps that we just had there. And then they have a puller similar to what we used on the bench with the pilot to pull it off, right? So nothing, you didn't miss anything there other than doing it on the vehicle. And then to reinstall it, same thing that we did. So they first, I guess I'm going to do it in this order because they do it in the order that you read it, but you end up putting the coil on first, and then you end up using this tool to put the clutch rotor on. The coil, I think, would be shown down here. So I'll talk to it about here first, right? So they tell you that when you put this, actually no, this is not it. Hold on a second. This one, sorry, wrong page. So they talk to you about putting the coil on with a similar kind of tool that looks like a puller, but it's a press and a different type of pilot, right? And then they talk to you about staking the aluminum to the outside metal in 3 places. Remember I said I was expecting to see that. Looks like GM doesn't do that anymore. But what they used to do is stake it at 3 places 120 degrees apart to help keep it from coming out. And this just show you like that. They just stake it in these 3 spots here. That's how they would have put that on. And then they would have went to this section to put the rotor back on. So we're not missing anything here. But they also would have staked the bearing and the rotor, something else that we didn't see on this version, so they don't do that anymore either to save money. And then when you get the clutch plate put back on using this tool here, which is similar to the aftermarket tool, there's the air gap specification from 0.20 to 0.30 thousandths of an inch. So hopefully this little bit of information in the service manual helps show you the differences between doing it on the bench and doing it on the vehicle. Anyway, we have got this fixed. If you've got questions or comments about this repair, go ahead and leave it below. I tried to include as much detail as I could while I did this. If you found that this saved you some money or taught you something, or you just found it entertaining, I appreciate you paying it forward by hitting that like button. And as always, thanks for watching.